Hello everyone, snowscan here. Today we're going to be doing Klendathu from Vulnlab, which is an insane difficulty box chain. We've got some authentication coercion on a Microsoft SQL server to get a service account. Then we will create a silver ticket to escalate our privileges in the database and then ultimately gain system access on one server. Then we'll pivot to a Linux host that is domain joined by modifying some LDAP attributes. And then finally, we'll get administrator in the domain by decrypting remote desktop connection manager credentials using the domain backup DPAPI key. So let's get started. First, we're going to run the Parscan on the lab. I'll just save that to scan TCP. I already have a text file with the IP addresses of the targets. This is going to take some time to run, so I'll just cancel that and instead show you the results that I have saved here. So DC1 is our domain controller. Nothing really special, all the standard ports. For SRV1, we see that this is running Microsoft SQL Server on 1433. This one is a bit odd, port number 1. Let's just say that this is a configuration mistake that the sysadmin made when he configured the SQL Server configuration. We can ignore that port. We'll stick to this port here. And then finally, we have SRV2. So that's a domain joined Linux server. Port 22 is open, and we also have 2049, which is the NFS port. So let's go back to our console here. Clear that. We don't have any credentials at the moment in the domain. So we could try doing AS roast to find some hashes to crack, but we're not going to be able to do that in this case. There's no AS rep roastable account in this domain. So instead, we're going to take a look at the NFS share and see if it's accessible to our IP address. So we're going to do show mount, give it the IP of the host. And then we see that the NFS share is exported to the wildcard. So that means that anyone can connect to that share. So what we'll do is we'll just mount that to our local drive. And then we'll see if there's anything good on that share. Got a little typo here. So let's mount that to our mount NFS and let's see what's going on. All right, so in the NFS share, we have a switch configuration file. So that's a Cisco config file. We have a password hash here. We have a plain text password, and we got a contact information here. So that's possibly a domain username. So we'll just write that down, and then we'll get the hash. We could try the plain text password, but instead we'll just start with the hash and see if we can crack that. Put that in that text file. Then we'll just use John the Ripper to crack it. Pretty weak password, football 22. So we're able to crack that. Now let's confirm if the credentials are valid in the domain. So we'll use netexec against the domain controller. Give it the Zim username, then football 22. Okay, so the credentials are good. We got that green plus sign here. Let's check all the shares and users while we're at it. So these are the typical shares, but we have this Deers share that's readable. We'll take a look to see if there's any directory on there that we can read. So we'll just wait for this output to complete. We can save that if we need that later. Now we'll just use an Mpacket SMB client to connect to the domain controller and see if there's anything good in that omdirs. So within packet, just listing the shares, we'll go to omdirs. There's 4 directories. Let's see if we can read any one of them. Doesn't seem like we have any access. So we have access denied everywhere. So let's ignore that for now. Doesn't seem that there's anything we can do here. Next, let's do a BloodHound collection to take a capture of the domain and see if there's any access list or group membership or anything special that we can leverage. So we'll do DC only. Then we're going to give it the credential and then the IP address of the domain controller, which is the DNS server. Looks good. All right, so we're successfully authenticated. We've got our TGT. We're pulling the info from the domain. And this is going to give us a bunch of JSON files. I've already imported the data previously in BloodHound, so let's look at that. So that's our user Zim. If we click on the user, we can see the group memberships. We're a member of NetAdmins. Maybe this group has access somewhere in the network. Not quite sure. We're also domain users. Another thing that we want to look at is maybe look at the outbound object control. See if we have any kind of outbound control on other objects. In this case, there really isn't anything. We're just a member of domain users in NetAdmins. But if we look at all the other users in the domain or groups, so we could do a search for admin. These are all like the typical admin groups. But we do see here that there's other admin groups. So we have NetAdmins, Linux admins. So these guys are probably have access to Linux servers. So we got those 2 users and Linux admins. There's also a database admins group with this guy here. So potentially we might be able to use that to access the database server. But really we don't have more access with Zim at the moment. So let's keep looking, right? If you go back here, one thing that we could try to do is see if we have any kind of access to the database server using our Zim user account. So for this, we'll use the MS SQL client in Packet. We'll just connect using Windows authentication. Football 22. And then connect to SRV1. Okay, so good news, we're able to connect, but we only have guest access. So we're not going to be able to do XP command shell and get code execution this way. One thing that we could look at is using Decrypting, which is a stored procedure. You can use this to look at the contents of local drive or even remote drives using a UNC path. So typically this could be used to get the NTLM v2 hash of the service account. In this case, though, the stored procedure is blocked. So there's been some hardening script applied to the server. So we're not able to use the Decrypting stored procedure. There's a couple of other ones that we could use. There's a couple of different blog posts and cheat sheets and stuff on GitHub. We could try a few of them. Most of them are blocked or don't work or require sysadmin access. But there's another one that is not blocked. So by doing some research, eventually you could find a couple of questions asked on Microsoft's website. There's one called sysdm os file exists, which is some kind of internal stored procedure or command in Microsoft SQL Server, and this one is not blocked. So if we just take that and then let's see if we can use that to get the hash. So I'll just start responder on tunnel 0. And then here I'm gonna put the IP address of my machine. Okay, so it looks like that we're getting somewhere. So we have this service account and we have the NTLM v2 hash here. So we'll just cancel that. And let's see if we can crack that. We'll just create a new text file, put the hash in there, and then we'll just run John the Ripper again. Okay, good. So this guy also uses a weak password. So Starship 99 it is. So we go here. Let's see what this guy has access to. So first degree group memberships, nothing really special, just domain users. Now outbound object control. Okay, this is the interesting part. We have, zoom in a little bit. We have force change password and generic write on Ibanez and Rico. So force change password, pretty self-explanatory. We can reset the password of those two accounts and take those accounts over. And we also have generic write that will allow us to write any LDAP attribute on those user accounts. But before we move on to taking over those accounts, what we can do to get the flag on SRV1 is to create a silver ticket. So the silver ticket technique, it's normally you would use that if you add the NT hash of the machine account. Then you could craft a ticket and impersonate domain user accounts on the machine itself. So like you could escalate access on a server. But in this case, we don't have the NT hash of the machine, but only the service account for the SQL server. But we can still use this. So what we'll do is we'll impersonate a database admin on the server, and then we'll escalate from there. So just going back real quick here to BloodHound, we do database admins. So this is the guy that we want to impersonate. Okay, so we'll just create the ticket with packet ticketer. We need the NT hash of Starship 99. So one way to do that is to use CyberChef. There's a recipe for NT hash. Just put in the password. We'll use this. By the way, for those who don't know, the NT hash is really just, you take the password, you just encode it UTF-16LE, and then you do an MD4 on that, and that's the NT hash. So need the NT hash, and then we'll give it the domain SID. The domain SID, you could get that from BloodHound as well. Just take any object SID, get rid of the last part, and that's going to give the domain SID. And then for the SPN, we want MS SQL. We need to specify the host name and the user that we want to impersonate. So that's going to generate a ticket for us. To use the ticket, we just set the Kerberos name environment variable. We check with klist that everything looks good. And then we will use SQL client again to authenticate. Like this. We just give it a -K for Kerberos authentication. So now we're logged in. We don't have the guest anymore, so we probably have sysadmin access. So let's do XP command shell who am I. Okay, it's blocked, blah, blah, blah. Okay, so it's not enabled yet. So let's do that. Fortunately, SQL client from Impacket already has a bunch of macros. So we'll just run that, enable command shell, XP command shell. All right, so we're good. We now have code execution with the service account. Another thing that we want to check is what kind of privileges we have. So as expected, by default, SQL Server in Windows runs with SE impersonate privilege. We can basically use this to get system access pretty easily. We can use like tools like God Potato or Juicy Potato or those kinds of things. So in this case, we'll just use God Potato to get a system shell. In this case, I'll use a sliver for my C2. Like Metasploit would work as well. So I'll just I'll generate a new payload, give it the MTLS path. I'm disabling the obfuscation so it generates faster. There's no AV on this box anyways, so we'll just go with, actually I already generated one. So let me just remove the previous one, implants. All right, let's just regenerate it. Yeah, so as I said, there's no AV, so we can just use like a regular implant without any obfuscation or anything special. So going back here, what we'll do is we'll just fetch it via curl. Just want to make sure that my web server is running. Yes. So let's fetch that using curl. We'll put that in program data. I will also fetch God Potato. Technically, I guess I could reflectively load it through the sliver agent, but I'm just lazy. I'll just grab the exe and drop it on disk. Totally not OPSEC safe, but not too worried about that right now. So let's run God Potato, give it the command that we want to run. So let's run sliver. Oh, I messed up something. Program data. There we go. So let's look at the sliver console. There's a new session. So it looks like we got our shell on SRV1. So at this point, we should be able to get the first flag. Get the flag here for SRV1. There's really nothing else on this box. You could try to get credential from the registry, dump LSAS, dump the SAM database, LSA, secrets, and all that stuff. But there really isn't anything else on this box. So let's move on to the next part. I'll just exit out of there since we have the agent running. So if we go back to BloodHound and look at this user here. So in the outbound object control, we saw that we have a generic right on those two accounts. And we also have the ability to change the password. So let's just change the password first and take over one of the account. So we'll start with NetRPC. There's a couple of different ways to do it on Linux, but let's do it with NetRPC. So I'll use NetRPC, then I'll give it the credential of the account that I control, connect to the domain controller. So let's pick a new password for Ibanez. Let's do Starship 11, super secure password. And then let's just validate that the creds are good. Okay, so it's good. We got our creds there. So now what can we do with this account? Well, we can only change LDAP attributes with generic rights. So at first glance, that doesn't seem to be anything else we can do. But doing some research by Googling, we'll find there is a DEF CON presentation from Ethical Chaos where he talks about the different ways that Active Directory uses to match the user when you authenticate. So if you're on Windows, the name type is going to be principal, and it's going to use the SAM account name to match the account when someone authenticates. But there's also the enterprise name type that could be used, and that's used mainly by Linux. It's not used by Windows. But in this case, it would use the user principal name, and if it doesn't exist, then it's going to fall back to SAM account name. So if we can control that attribute, then potentially we can play tricks with the authentication from the Linux server. Let's see if we can modify that and change the Ibanez user principal name to a Linux administrator account. The Linux admins, we have those two guys. So we have Flores and Levy. So let's take over this account here, or I should say, let's impersonate this guy. So Levy. So what we'll do is we'll use, we could use any LDAP shell. There's a bunch of different ways that we can modify the LDAP attribute. In this case, I'll just use Apache Directory Studio just because it's easier to visualize. So I've already pre-populated the credential of the RasJack account. We have to use this account because a user is not allowed to edit or modify its own user principal attribute. So we have to use this account that has a generic right on Ibanez and Rico. So I'll connect to the domain. Then let's look at the users list. This is the account that we've changed the password to. And we don't have a user principal attribute set. So let's create a new one, new user attribute. Just go next. And then we'll set the attribute to Levy. There's another thing that we need to do before we can execute the attack. We need to modify Impacket so that we will authenticate with an enterprise type instead of principal. In the presentation, Ethical Chaos mentions a new update to Rubius where you can specify the enterprise principal type. We could use Rubius and then get the ticket converted from Kirby to CC cache and so on. But in this case, we'll just do it from Linux. So instead, I've already modified the Impacket, but it's really just one quick modification. So if we take a look at the get.tgt.py script, it's really just here on line 58. So the previous value was NT principal. I just changed it to NT enterprise. So just one small modification that's required. So what we'll do is we'll use the get.tgt. We'll give it the IP of our domain controller. Klendathu. Then we'll put the Linux admin username. And what's going to happen is that the search, it will match the user principal name, and then it will go to the Ibanez account that we control. So right now I'm entering the password for Ibanez. So I entered Starship 11. So we obtain a ticket for Libby. So I'll just set the KRB5CC name. Let's check with KList that everything's good. We'll just check that our KRB5 configuration is set correctly. So really the only thing you need in that config file is to set your realm, make sure that you have your KDC configured and the domain realm configuration. And then USSH, just doing with the capital K, that's going to use Kerberos authentication. Klendathu SRV2. and hopefully we should be able to connect. Okay, so we're successfully logged in as Livy. We're domain users, we're Linux admins. So let's look at the sudo configuration. So privilege escalation on this box is pretty easy. So they have a config set so that you can just SU directly to root. So 2 blocks down, 1 to go. So we got the flag here. So we'll do some enumeration on the Linux server to see if there's anything we can use to pwn the next box. There's a folder here called inc something domain controller backup. Let's look at the contents of the directory. Okay, so it looks like it's a domain controller backup. We got the registry hive backup here. We got the NTDS DIT, which is the full AD database, and there's also a note. So let's look at the note. So it looks like they had some kind of breach, and they took a backup of the domain controller and they reset all the passwords. So we'll just create an archive of this folder and the TMP so that we can copy it via SCP. I'll just grab that, create TGZ. Another thing that we want to look at potentially is using the key tab file. So in the etc directory, there's the Kerberos key tab file. So it basically contains the credentials of the machine account. So we could copy that offline and use a tool called a key tab extractor, and that would give us the NT hash of the machine account. And potentially we could use this to maybe like take a look at BloodHound, see if the machine account has any kind of access. But in this case, there's really nothing we can do with that machine account. So we'll just keep looking. There's also the TMP folder. That's a common default location where Kerberos tickets are saved. So if you log on to a Linux server with like explicit credentials, it's going to request a TGT and we'll save it to the TMP folder. Or depending on the configuration, it might save it to the keyring or like other locations. But in this case, it's being saved to TMP. So if you get root on a domain join Linux box, you really want to take a look at that. So in this case, we have a TGT for SVC backup. So we'll just really, I'll just copy that easily by doing base64 encoding. I'll get that right here. I'll log out of the box. Base64 decode. Then I'll just save that to a ticket locally on my system. Next, I'll just go fetch the domain controller backup that I created, that I copied over to TMP, I should say. What's the file name? Yeah. Okay, so let's extract that. Normally, like the first instinct that we have could be to use something like secrets dump to parse the backup and extract all the ND hashes. So let's just do that for demonstration purposes. So we'll use secrets dump. We give it the NTDS database. We need the system registry hive where the boot key is located, and then we just add the local keyword at the end. And then you can see here we have all the NT hashes of all the domain users and the AES keys. So if we try as a quick check, we could try to authenticate with the administrator account and see if we're able to. Okay, so it looks like that they rotated all the passwords after the last breach. So we're not going to be able to use any of the user hashes in that database dump. one thing to keep in mind is even if they change all the user accounts, if they forgot to rotate the KRB TGT account, then we could use this to create a golden ticket and then impersonate any users without knowledge of their NT-hash or password. But in this case, I mean, we could try it, but they already changed the KRB TGT account twice. So this attack will not work in this case. So let's just keep looking at other stuff that we have. So we have the SVC backup ticket that we copied from the box. So let's see if we can use this to access something in the network. Let's just look at BloodHound real quick. So in the description, we have legacy account, sync data to users' home directories. So we had this home dirs share that we found initially, but we couldn't access. So let's just go back and see if we can browse that share now. So I'll just set the ticket. Then we'll use SMB client. I don't even need to give it the use. Okay, so I think I messed up the ticket, or it expired or something. So what did I do wrong? Let's just take a look at that again. So I did klist. Oh, I put CC cache. It's not CC cache, it's CC name. So let's just fix that real quick. Okay. All right, so we're good. We're able to access the directories now. So the Jenkins folder has two files. So we have an RDG file. So that's a remote desktop connection manager config file. So we'll grab that, and we have an archive here. So if we look at the RDG file, what we have is we have the username and password for the domain admin account, but the password is encrypted. So Remote Desktop Connection Manager uses DPAPI to encrypt the credential. So the password is going to be encrypted with with a key, and the key is encrypted with the user's password. So unless we have the password of the Jenkins user, we're not going to be able to decrypt the password so easily. And because they changed all the passwords since the last breach, then we can't really use the domain backup to help us with getting the password for the account. But one thing that has not been changed is the domain DPAPI backup keys. So when you encrypt credentials with DPAPI on a domain joined system, they're going to be encrypted with the user's password, but it will also be encrypted with a domain backup key, and that key is stored on the domain controller, and there is no official Microsoft supported way of changing that key, or at least not that I know of. So even if they change all the passwords in the domain, the incident responders or sysadmins, they probably forgot to change those keys, or they did not think about that. We'll use that to get the domain DPAPI backup keys and decrypt the credentials. Okay, so the first thing we need is we need to extract the roaming of a folder of the user. Yes, always. Okay. Oop. Where is that? Oh, there we go. Roaming. So the files that we need they're in the protect folder here. So we need roaming Microsoft protect. And this is the encrypted backup key on that system. But we also need the private key stored on the domain controller. So what we'll do is we'll go to the folder that we copied, and then we're going to use a tool called NTDS dissector. I think I have it here from Synactive. It basically parses the NTDS DIT and will output a whole bunch of things, including the secrets and private keys for the backup key and so on. Okay, so we'll just go here, and then we'll do NT dissector, NTDS. And then output directory. Okay, so we parsed all the data. Now in the out directory, we should have new folder. And then in the secret.json, what we're looking for is the backup key, current value. So we need the PVK, so that's a private key. So we'll just take that. Then I will decode that to DPAPI.pvk. So we got the private key, and we got the RDG file, and we got the roaming folder that has the backup key encrypted secret. So for the next part, we could use Mimikatz. There's a module for DPAPI, but a much easier way is to use a script called RDG decrypt. There's a repo here by this guy. There's a whole bunch of scripts that will facilitate the decryption of various tools. So in this case, I'll use RDG decrypt. So I think I put it here. So the RDG decrypt. We want to decrypt the RDG file. We need to give it the SID of the user. So that was Jenkins. So for the master key, so we just need to give it the path to the protect folder. So I'll just put this like that. Then we give it the DPAPI backup key, and hopefully it should decrypt the admin password. Okay, good. So we've decrypted the RDG file. You get the admin password right here. Now, all that's left is just to connect. And there we have it. We have the root flag right here. Okay, so that's it for this box. I hope you enjoyed, and see you next time around.